Now, coming to part 2 of lecture 1 of our week 6, where we are going to study about voltage regulation. Now, for examples of different regulators, first we need to introduce a certain topic, that is a clipper circuit. So what does a clipper circuit do? A clipper circuit certainly just clips, or it cuts off the signal at a certain level, which means whatever the input signal is going to be, the output is just going to be a single valued line. It means it is just not always line, or it just clips off anything that is above a certain level, or we can also say it clips off anything that is below a certain level. So we are going to study these different kinds of clipper circuits but normally a clipper circuit is just a circuit that cuts off a signal, that cuts off anything of a signal that is above a certain value or lower a certain value. Means, say we have a circuit like this where we have a resistor and a diode. So if I take the output from the diode, I know that I am always going to get a VD0 output if my input signal is greater than VD0 according to constant voltage drop model. Because if my input signal is greater than VD0, this diode is going to be on, and then there's going to be a current flow, so we are just going to get the VD0 at the output. But if the input signal is lower than that, we are not going to get any current flow through these diodes, so just the input is going to come to the output. So just if we think whatever my input signal is, say my input signal is something like this, say it peaks at 10 volt and it gets the negative peak at minus 10 volt. So whenever my input signal is greater than 0.7 volt, I know that my diode is going to be in forward biased. So at the diode end, if I take the output V out, I'm just going to get 0.7 volt. So whenever my input is greater than 0.7 volt, it is just going to clip the signal off at 0.7 volt. That is why it is called a clipper circuit. But coming to the concept of regulation, what we thought, or we explained the regulators are that they give a certain valued output that does not change with input fluctuations. So here we can see that whatever my signal is above 0.7 volt, my output does not change. My output is fixed at 0.7 volt. So we know that this is kind of a regulator, and this is called a hard limiter because the output is hardly fixed at 0.7 volt because we are considering the CVD model, the constant voltage drop model. But in real world, things are not so ideal. So in real world, we do not get hard limiters. In real world, we get soft limiters. So what are they? Now, if we add a resistance of the diode with our CVD model, that is the concept or the model used in soft limiters, where here we use the CVD plus R model. Means there is some kind of equivalent resistance of the diode, and when we are taking the output, this resistance of this diode is also going to play some role in our regulation. So here what happens is that before 0.7 volt, obviously this diode is not turned on because that is its turn on voltage, and before that the forward bias is not working, it is in reverse bias. So this V out part is not actually getting any current flow, so the input gets to the output. So before VD0, it is kind of the same as the hard limiter, but in soft limiter, the change occurs because of this R, this equivalent resistance of this diode. So here we do not actually actually get a straight line like hard limiters. We get a slopy line. We get a line with the slope of small r divided by capital R plus a small r, where small r is the equivalent resistance of the diode and capital R is just the input resistance of this circuit, which we are going to see in future that it also plays some kind of role in regulation, but not now. So this slope here indicates that we are not getting hard limiters, we are getting soft limiters here. So we need this slope to be as small as possible, because when this slope is smaller, this slopy line kind of follows the line that we get in hard limiters, because the lower the slope, the similar it becomes like hard limiters. And we also want that we need to have a constant valued output. So we need the slope to be as small as possible. Now, our output previously was only VD0, but in case of soft limiters, our output is now VD0 plus this small r divided by capital R plus small r into Vin. So our soft limiters are the ones that we get in real world. We do not get hard limiters, and here we use CVD plus R model. Now, this is also a voltage regulator, because we are regulating our output. We are controlling the output and we are trying to keep it at a certain level, whatever the change in the input occurs. So how do we compare voltage regulators? So there are two ways. One is the line regulation and two is the load regulation. So before going into line regulation and load regulation, first we want to see how do you know that a voltage regulator is a good one. So to know that our regulator is working properly and it is a good regulator, we need to see that if our output is keeping at a certain level when whatever our changes in the input is, and say if it can sustain some sort of disturbance or some sort of changes in the inputs, and it keeps the output at a certain level, we know that this regulator is a good one. So next we're going to study about line regulation and load regulation and how they can be measured.